So let's start with the fifth part of the tutorial, machine learning. Now here we are going to discuss the support vector machine, which is again a very important algorithm which can be developed using these details. Like support vector machines are powerful yet flexible supervised machine learning algorithm which are both used for classification and regression. Now support vector machine is one of the widely used technique for classification and regression. It offers very high accuracy compared to other classifiers such as logistic regression and decision trees. It is known for its kernel trick to handle non-linear input spaces also. It is used for a variety of applications such as face detection, intrusion detection, classification of emails, news articles and web pages, classification of genes, and handwriting recognition. Now before we move further, let us try to understand SVM with a small story. The story goes like this. A few days ago, there was a child whose father was buying some fruits from a fruit seller. The child wanted to eat a strawberry but got confused between the two similar looking fruits. After noticing for a while, he understands which one is a strawberry and picks one from the basket. Almost in the same manner as the child got confused, support vector machines work. Now it looks at data, sorts, classifies, etc. into one, and then finally you decide. So then finally it is decided what is the correct one. So support vector machine is one such algorithm. It is considered as the black box technique as there are unknown parameters that are not so easy to interpret and assume how it works. It depends on three working principles. Number one, maximum margin classifiers, support vector classifier, and support vector machines. Let's try and understand each principle in depth. Now maximum margin classifier, they are often generalized with support vector machines, but SVM has many more parameters compared to it. The maximum margin classifier considers a hyperplane with the maximum separation width to classify the data. But infinite hyperplanes can be drawn in a set of data. It is indeed important to choose the ideal hyperplane for classification, as you are seeing in the pictures. Support vector classifiers, this types of classifier can be regarded and as an extended version of the maximum margin classifier, which also deals with the non-separable cases. When we deal with real life data, we find most of the observations are in overlapping classes. This is why we use support vector classifiers. Let's consider a tuning parameter C. In this classifier, the high value of C can give us a robust model. A lower value of C gives us a flexible model. Let's understand with the following diagram. Now here you can see the C support vector classifier with the large value of C. Now see where it is, what is the condition of the line that you are drawing on the hyperplane, and with the small value of C, how close these lines are. So that is how we can easily decide as to what is the, which one is to be accepted. Support vector machines approach is considered during a non-linear decision, and data is not separable by a support vector classifier, irrespective of the cost function. Now the diagram illustrates the inseparable classes in one-dimensional and two-dimensional spaces. When it is almost difficult to separate non-linear classes, we can apply another trick called kernel trick that helps handle the data. Now in the above diagram, the data that was inseparable in one dimension got separated once it was transformed into two dimensions. So we transform from single dimension to the two dimension, and after applying a polynomial kernel of the second degree, now let us see how to handle the two-dimensional linearly separable data. So you can see that the data which is appearing in the left picture, which is circular type, has been separated with the hyperplane, and we got the blue balls and the red balls separated. So that is what can be done with the help of this SVM approach. In two-dimensional data, the polynomial kernel of the second degree is applied by using linear plane after transforming it to a higher dimension. Now, some salient feature of the SVM, it supports vector machine is mainly used for classification, can easily handle multiple continuous and categorical variables. SVM constructs a hyperplane in multidimensional space to separate different classes. SVM generates optimal hyperplane in an iterative manner, which is used to minimize an error. The core idea of SVM is to find a maximum marginal hyperplane that best divides the data set into classes. So again, you can see in this picture, which is shown in this screen, that how it is divided into two different types of data points. Now, support vectors are the data points which are closest to the hyperplane, and these points will define the separating line better by calculating margin. So you can calculate the margin, and these points are more relevant to the construction of the classifier. So you can easily say that yes, the points that are close to the middle path, that is red line, they are having lesser margins. A hyperplane is a decision plane which separates between a set of objects having different class memberships. Now, margin is a gap between the two lines to the closest class points. This is calculated as the perpendicular distance from the line to support vectors or closest points. If the margin is larger in between the classes, then it is considered as a good margin. A small margin is a bad margin. So that is why this can be understood with the help of by drawing the lines, etc. These support vectors are the coordinate representations of individual observations. It's a common method for segregating the two classes. Now, how does SVM work? The basic principle behind the working of support vector machine is simple. Create a hyperplane that separates the two data sets into two classes. Let's start with a simple problem. Suppose that for a given data set, we have a classify red squares from blue circles. The goal is to create a line that classifies the data into two classes, creating a distinction between red squares and the blue circles. Now, where one can hypothesize a clear line that separates the two classes, there can be many lines that can do this job. Therefore, there is not a single line you can agree on which we can perform this task. Let us visualize some of the lines that can differentiate between the two classes as follows. In the above visualization, we have a green line and a red line. Which one do you think would better differentiate the data into two classes? Now, if you choose the red line, then it is ideal line that partitions the two classes properly, which is very, very obvious. You can see on the picture. And however, we still have not concretized the fact that it is the universal line that would classify our data most efficiently. So we have to see that whether this is the most appropriate, most acceptable line. The green line cannot be the ideal line as it lies too close to the red class. Therefore, it does not provide a proper generalization, which is our end goal. Now, according to SVM, we have to find the points that lie closest to both the classes. These points are known as support vectors. In the next step, we find the proximity between our dividing plane and the support vectors. The distance between the point and the dividing line is known as margin. The aim of an SVM algorithm is to maximize this very margin. When the margin reaches its maximum, the hyperplane becomes the optimal one, which again is visible on your screen. Now, SVM model tries to enlarge the distance between the two classes by creating well-defined decision boundary. In the above case, our hyperplane divided the data while our data was in 2 dimensions. The hyperplane was of 1 dimension. For higher dimensions, say in n-dimensional Euclidean space, we have n-1 dimensions. Subset that divides the space into 2 disconnected components. because in Euclidean space you can have as many hyperplanes as you want. So then we have to make this, use this kind of a analogy. Now SVM's objective, the main objective of SVM is to segregate the given data set in the best possible way. The distance between the either nearest points is known as the margin. The objective is to select a hyperplane with the maximum possible margin between support vectors in the given data set. So the SVM searches for the maximum margin hyperplane in the following steps. Number 1, generate hyperplanes which segregates the classes in the best way. Now again you can see the two pictures, how it appears, and you can easily, just by looking at the picture itself, you can easily understand. But the second point is that left hand side figure showing 3 hyperplanes, that is orange, black and blue, and then you can see that here the blue and orange have higher classification error, but the black is separating the two classes correctly. So you can, just by observing it, you can make out. Then the next is select the right hyperplane with the maximum segregation from the nearest data point as shown in the right hand side figure. Now how to deal with nonlinear and inseparable planes? That is, data is not always linear, as we know. As such, some problems can't be solved using a linear hyperplane as shown. Now in such situation, SVM uses a kernel trick. The kernel trick which we discussed in the beginning. So that trick is to be used here to transform the input space to a higher dimensional space as shown in the right side. Now the data points are plotted on the x-axis and z-axis. Z is the squared sum of both x and y, as that is shown in the equation, that is z is equal to x square plus y square. Now you can easily segregate these points using linear separation. So on the left hand side you can see that the data points are circular, which we have by using this we have now separated into 2. So that z plane which has been introduced, now you can do that. Now SVM kernels. The SVM algorithm is implemented in practice using a kernel. A kernel transforms an input data space into a required form. SVM uses a technique called the kernel trick, and here the kernel takes a low dimensional input space and transforms it into higher dimensional space. We can also say that it converts non-separable problem to separable problem by adding more dimensions to it. It is most useful in non-linear separation problem. Kernel trick helps us build a more accurate classifier, which again you can see in this picture. Now types of kernel. Linear kernel, that is, a linear kernel can be used as normal dot product between any two given observations. The product between two vectors is the sum of the multiplication of each pair of input values. Then there is the polynomial kernel. A polynomial kernel is a more generalized form of the linear kernel. The polynomial kernel can distinguish curved or non-linear input space, where d is the degree of the polynomial and d is equal to 1 is similar to the linear transformation. The degree needs to be manually specified in the learning algorithm. Radial basis function kernel. The radial basis function kernel is a popular kernel function commonly used in support vector machine classification. RBF can map an input space in infinite dimensional space, and it is the most used kernel. Now advantages of SVM: guaranteed optimally. Owing to the nature of convex optimization, the solution will always be global minimum, not a local one, not a local minimum. Abundance of implementation. We can access it conveniently, be it from Python or MATLAB. SVM can be used for linearly separable as well as non-linearly separable data. Linearly separable data is the hard margin, whereas non-linearly separable data poses a soft margin. SVM provides compliance to the semi-supervised learning model. It can be used in areas where the data is labeled as well as unlabeled. It only requires a condition to the minimization problem, which is known as the transductive SVM. However, feature mapping used to be quite a load into the computational complexity of the overall training performance of the model. Then, however, within the help of the kernel trick, SVM can carry out the feature mapping using simple dot product. SVM classifiers offer good accuracy and perform faster prediction compared to the naive-based algorithm. They use less memory because they use a subset of training points in the decision phase. SVM works well with the clear margin of separation and with high dimensional space. Some disadvantage about SVM. SVM is incapable of handling text structures. This leads to loss of sequential information and thereby leading to bad performance. Vanilla SVM cannot return the probabilities confidence value that is similar to logistic regression. This does not provide much explanation as confidence of prediction is important in several applications. Choice of the kernel is perhaps the biggest limitation of the support vector machine. Considering so many kernels present, it becomes difficult to choose the right one for the data. How to tune SVM parameters? Now, kernel is going to be used for that. Kernel is the SVM is responsible for transforming the input data into required format. Some of the kernels used in SVM are linear, polynomial, and radial basis function. For creating a non-linear hyperplane, we use RBF and polynomial function. For complex application, one should use more advanced kernels to separate classes that are non-linear in nature. With this transformation, one can obtain accurate classifiers. Now, regularization, C, as we have seen earlier also, C is a regularization parameter that controls the trade-off between the achieving the low training error and a low testing error. That is ability to generalize the classifier to unseen data. Gamma, with a lower value of gamma, we will create a loose fit of the training data set. On the contrary, a high value of gamma will allow the model to get fit more appropriately. So the gamma parameter defines how far the influence of a single training example reaches, with low value meaning far and high value meaning close. A low value of gamma only provides consideration to the nearby points for the calculation of a separate plane, whereas high value of gamma will consider all the data points to calculate the final separation line. Now, application of SVM, some of the areas where support vector machines are used are as follows, like face detection. Now, SVMs are capable of classifying images of persons in an environment by creating a square box, as you can see in the picture, that separates the face from the rest. Then health sector. In health sector, SVM can be applied in this sector also to predict the condition of the patient, also to predict the chances of dangerous diseases. It also plays a large role in medicine composition. Banking sector, it can be used to predict the nature of fraudulent customers and can also predict the credit risk. During the sanction of a loan, it can predict the eligibility of a customer. Then third is this social networking domain. It can handle large amount of unstructured data such as text. This is why it is used to classify types of text in social networking platforms. Then text and hypertext categorizations. SVM can be used for document classification in the sense that it performs the text and hypertext categorization based on score generated. It performs a comparison with the threshold value. Then bioinformatics. In the field of bioinformatics, SVMs are used for protein and genome classification. They can classify the genetic structure of the patients based on their biological problems. Handwriting recognition. Another area where support vector machines are used for visual recognition is handwriting, and there also it is being quite extensively. So this completes this tutorial, and the last tutorial we are going to switch now. Thank you.